Welcome to another episode of arXiv Preprint Server Daily, AI Frontiers, where the latest research shaping artificial intelligence and related fields is brought to light. Today's spotlight is on cutting-edge innovations in computer vision, drawn from a remarkable collection of 68 papers published on April 30, 2025. This episode uncovers key themes, groundbreaking findings, and future directions in this dynamic field. Join us on a journey through the visual frontier, exploring how machines are learning to see and interpret the world in ways that mirror human perception. Let's begin with an overview of computer vision, a cornerstone of modern AI. This subfield of computer science focuses on enabling machines to interpret images and videos, much like the human visual system. Key tasks include object recognition, motion tracking, and 3D scene reconstruction. It powers transformative technologies such as facial recognition in smartphones, autonomous vehicles navigating complex environments, and medical imaging for diagnostics. By bridging raw visual data to actionable insights, computer vision drives real-world applications. The 68 papers under review today highlight its diverse challenges and breakthroughs. One prominent research theme from these papers is generative models for visual content. This area focuses on creating realistic images, videos, and 3D scenes using advanced AI. For example, diffusion models are being used to generate sewing patterns for garments and transform single images into stereoscopic 3D videos. Technically, diffusion models work by iteratively denoising data to produce high-quality outputs. While their strength lies in stunning realism, a notable challenge is their high computational cost. This theme pushes boundaries in creative industries and virtual reality applications. Another significant theme is multimodal learning, which integrates visual data with other inputs like text or audio for deeper understanding. A standout example is the use of vision language models to enhance decision-making in autonomous driving, as explored by Lubberstedt and colleagues. These models align visual and textual data to excel in contextual tasks. However, they often struggle with fine-grained details. This approach broadens AI's capacity to mimic human-like perception across various domains. The third theme is robustness and generalization, emphasizing models that perform reliably under diverse, real-world conditions. Research addresses issues like domain gaps in image dehazing and sensitivity in holographic systems, as studied by Amruth and team. The goal is to ensure consistent performance beyond controlled lab settings. A key challenge remains the need for extensive data or computational resources. This focus is critical for practical deployment in varied, unpredictable environments. A fourth theme, video understanding and dynamics, centers on analyzing and generating video content with consistent, believable motion. New metrics to assess motion realism in generated videos are proposed, notably by Allen and colleagues. Research also includes frameworks for interactive video generation, enhancing dynamic user experiences. This area is vital for applications in animation, virtual reality, and cinematic content, effectively bridging static images to lifelike temporal sequences. Turning to key findings, several breakthroughs from these papers stand out for their potential impact on computer vision. Diffusion-based methods for facial privacy protection evade recognition systems while maintaining natural appearances. Innovations in 3D scene generation from panoramic videos create immersive 4D experiences. New metrics for brain MRI generative models prioritize anatomical fidelity for medical applications. Lightweight vision language models achieve efficient video summarization, and self-supervised learning democratizes 3D modeling of common objects. Now, let's explore the core methodologies driving this research. Diffusion models produce high-quality visuals through iterative denoising but are computationally intensive. Vision language models offer contextual understanding, though precision can be a limitation. Self-supervised learning reduces the need for labeled data, yet may lack accuracy in complex tasks. Attention mechanisms in transformers focus on relevant data but are memory-intensive for high-resolution inputs. Finally, physics-inspired neural networks ensure realism by integrating physical principles, though their design can be complex. Diving deeper into specific studies, the first standout paper by Amruth and colleagues from 2025 focuses on holography innovation. Titled, Towards Robust and Generalizable Gerchberg-Saxton-Based Physics-Inspired Neural Networks, its objective is to improve holography for augmented reality using physics-inspired neural networks. A sensitivity analysis identifies critical factors like pixel resolution. Findings show free space propagation models excel in generalization. This work guides hardware design for reliable holographic displays, linking theory to practical, deployable solutions. The second highlighted paper, by Allen and team from 2025, is titled, Direct Motion Models for Assessing Generated Videos. Its objective is to develop metrics for evaluating realistic motion in generated videos. The method uses auto-encoded point tracks to assess temporal realism, outperforming traditional metrics and effectively localizing errors. This innovation refines video models for cinematic quality and virtual reality, redefining evaluation standards in video generation with significant practical impact. The third notable paper, by Lubberstedt and colleagues from 2025, introduces the V3LMA model, or Visual 3D Enhanced Language Model for autonomous driving. The goal is to enhance 3D understanding for safer autonomous navigation. By integrating vision language models with 3D object data efficiently, it achieves top benchmark scores for traffic scene comprehension. This improves real-time decision-making and offers a scalable solution, selected for its critical impact on safety in autonomous systems. Looking ahead, several exciting directions emerge for computer vision. Multimodal systems integrating vision, language, and physical constraints promise more holistic AI. Efficiency remains a focus, with lightweight models enabling broader, faster access. Ethical frameworks are needed to balance innovation with privacy and trust. Niche applications in medicine and agriculture highlight tailored solutions. Finally, robustness testing will be key to ensuring reliability amid real-world variability. Reflecting on today's exploration, it's evident that generative models and multimodal learning are redefining visual AI capabilities. Robustness and efficiency, as highlighted by Amrut Thakar and team, remain critical for real-world impact. Applications in autonomous driving and healthcare, as seen in Lubberstedt and colleagues' work, demonstrate transformative potential. Stay tuned for more insights with arXiv Preprint Server Daily. AI Frontiers as the journey through cutting-edge research continues. Before concluding, a quick look behind the scenes at how this content was synthesized. Advanced AI tools were utilized for efficiency and depth, with narrative structuring powered by the GPT model Grok 3 from xAI. Text-to-speech synthesis was enabled through Google tools for potential audio narration, and image generation for conceptual visualizations was also supported by Google. All content has been reviewed by a human expert to ensure accuracy and clarity. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.